Welcome back, minions, to Nick Does Maths. We've got some mechanics for you today. This is a question posted over on the Lun Gang Reddit. Go check it out. Some really cool stuff going on there. And if you have questions you'd like to ask, pop them on. We'll get round to them. So we've got a particle of mass 0.25 kg. It is subject to a driving force of this horrible expression, so there. It's also subject to a frictional force which is equal to its velocity. Initially it's at -2, it's travelling away from the origin at 1 meters per second, yada yada yada. Let's show this is true and let's solve it. Well, let's go. Now, if it's travelling away, we've got our frictional force of V newtons travelling that way. So, F equals ma. What is the total force? Well, we've got the, if we're taking to the right as positive, right? Let's take to the right as positive, it'll sort itself out. So what force have I got acting to the right? I've got V, which is x dot. All right, using standard dot notation, minus x plus 0.5, 1 plus 3t e to the 3t is equal to m times the acceleration, which is x double dot. Times by 4, times everything by 4. 4x dot minus 4x plus 2 times 1 plus 3t e to the 3t is equal to 2. It's just equal to x double dot. And if we move those terms over there, we're home and dry. We need the space. We're not going to write it out. Right, hence solve and show that this is true. That looks cool. Right, well, let's solve the complementary solution. So our complementary solution, I'm just going to go from here. Our auxiliary equation is lambda squared minus 4 lambda plus 4 is 0. That is lambda minus 2 squared is 0. Ahaha. This is where this is going to come on. So that is a repeated root. So that means that I am looking for something that looks like that. And I don't know why that's become a 3. That's a 2. That's a 2. Don't know why that happened. Probably because of that. Sneaky. Right. Because that is a repeated root. So we get the A and we get the BT. Now, our particular integral. Well, the right-hand side already is a linear function times e to the 2t. So what I need to do is I need to up those powers. Right? So normally I would multiply e to the 2t by t, but that's already there. So I need to go again. Right? And I need to go again. So what we're actually saying is we're going to look for something of the form a plus a t squared plus b t cubed e to the 2t. Right. Let's differentiate that. Differentiate this. 2at plus 3b t squared, keep that. Plus twice, plus differentiate that, keep this one. All right? Which is 2b cubed plus 3bt squared plus 2at squared plus 2a t. Differentiate that again. Excellent. 6b t squared plus 6b t plus 4a t plus 2a e to the 2t. Plus, we'll pull a 2 down, 4b t cubed plus 6b t squared plus 4a t squared plus 4a t. All right, so now we need to make them match. So if I plug that into here, and I'm going to play around with this over here, all right, we need to make this match. So I've got, let's check the t to the, what's the highest power I've got? T cubed? Right, let's check the t cubes. I've got x double dot, so what t cubes do I get from x double dot? I get this one. I get 4bt cubes. Minus 4x dot minus 8b t cubes from there, plus 4x plus 4b. And that should equal to this. There should be no t cubes. Well, that happens no matter what I choose for b. Sorted. Let's look at the t squares. So x double dot, how many t squares do I get? I'll get 6bt squared from there, 6bt squared from there. That is 12b t squared from there. Minus 4x dots, that's minus 12b. Well, that's already quite reassuring for me. Plus 4b. Differentiate 2at squared plus 3bt squared plus, 2a plus 2. Aha! Nope. 2at, 3bt squared, 2at squared, 2bt cubed. Yes. And then we differentiate that. 6bt squared, 6bt, 4at, 2a, and then we double all of that. 4bt cubed, 6bt squared, 4at squared, 4at. That is supposed to cancel out. And quite frankly, I don't like it. Let's try that again. So the t squares. Oh, it's because I haven't looked at the a's. That's right. Right, let's try that again. So I've got 6b plus 6b is 12b, and I've got 4a. So let's do this properly. Plus 4a t squared from there. Right, let's look at the t squared in there. So I've got minus 12b from there, and I've got minus 8a from there. T squared, there we go. And I've got 4 of these plus 4a, and that is equal to 0. It all cancels out no matter what. Okay, now we're back in the reality that I want to live in. That is how this should happen, right? If I'd had to go up and up and up in powers to match this, then the extra powers I'm pumping in should cancel out naturally. Now are the ones that are going to set the actual values of b and a. So, let's see if I can do this. I get 4at's from there. I get 6b and 4a from there, so that's 8a. And I get 6b from there and there. Right, minus that. That's minus 8a from there. Okay, b that way. Plus 4 of that, and there aren't any. So this isn't going to help us at all anymore. And that has got to equal to, how many t should I get? I should get 6 of them. So that tells me b is 1, which is reassuring. Right, because we should get 1. I should get a as 1 as well. Now let's look at the constant terms. Do I get constant terms? I get 2a from this one, minus nothing from there, I think. Nothing from there, nothing from there. So 2a has to equal to 2, which tells me that a is 1. All right, we got a little bit lost there, but there we go. So we get b is 1, a is 1, fine. That is what we wanted because they are the coefficient of t cubed and t squared. Now we need to find these coefficients, which come from my complementary solution, which is where we're going to match these. Allons-y. Right, now I'm going to keep these up because, I mean, they are vaguely useful for me. Well, I say that. So, we have the fact that x is equal to t cubed plus t squared plus a plus bt e to the 2t. In fact, these are not useful to me at all. We need to match my initial conditions. At t equals 0, x is minus 2, x dot is minus 1. Let's go. So, what is x dot? X dot is, differentiate all of that. 3t squared plus 2t plus b e to the 2t plus 2 lots of t cubed plus t squared plus a plus bt e to the 2t. Right, let's plug in t as 0. X should be minus 2. So what am I left with? 0, 0, 0. Ooh! A times 1. Awesome. Aha! I wanted that. And then x dot is minus 1. I'm left with b from that term, plus 2a. That tells me that minus 1 is b minus 4. That tells me b is 3. Naha! Which gives me xt is t cubed plus t squared. Let's do it nicely. 3t minus 2. Smiley face. Padoosh! Quite cool, this idea of repeated roots, plus we've got repeated roots, plus we've got this resonance with the right-hand forcing term. It's absolutely mental. I love it. I love it to bits. Cool, nice little bit of mechanics. If you enjoyed that, don't forget to like, subscribe, hit the notification button, drop us a comment, go check out our Lungang Reddit. Some really cool questions, great community over there. People just answer each other. It's amazing. Go hang out. I'm Nick. I will see you next time. See you then.